Hi everyone, welcome back. So today for all machine learning beginners, I brought to you KNN Neighbours notebook. This is my own college code. So we shall see from the scratch how we shall code and use KNN Neighbour, sklearn, Python libraries, numpy, pandas to build a KNN Neighbour model and train that model on our data and get predictions, see its accuracy, do pre-processing and lots more. So keep watching and I shall explain to you the code in detail so you shall get the basic simple idea of how to do this. So let's begin. So first, what is this? This is my code is on the drive. My dataset is stored on drive, so I have mounted my drive. This code you shall get directly when you click here. It gives mount drive. This code shall be inserted automatically. Now the main real part begins. This is the dataset link from where you can access the dataset, download it and use it for your own. Now as we begin, first of all, basic things that we need to import for any Colab project machine learning is pandas. So we import pandas as PED, numpy as NP, matplotlib.pyplot as PLT. After that we have to import our dataset. So it is in CSV format. CSV is comma separated values, that is Excel format. So we write pd pandas pd dot read CSV. Read CSV is a function that will read our CSV file and convert it into a data frame, and we will get data frame in D, stored in D variable. We print D, so we can see this is our data frame and our data that is stored in our CSV file. So what we have in this data, first column is the TID, that is the index. Second is refund, third is marital status, fourth is taxable income, and the last is evade, whether you can evade tax or not. So this was our data. Now we shall first of all see the statistics or analysis of the data. So the basic functions used are t.describe. This function gives all mathematical details of numerical columns in our dataset. So we had only one numerical column for the beginning. So we got only these details for TID. Rest all we did not get anything because it was not in numerical format. Another function used is t.info. This info function gives the type of each column and how many not null values are there. So as we can see, the TID is in integer format, rest are objects, and not null values are these. There are 10 not null values. Not null means not empty. Now for any model prediction, any data processing or any machine learning algorithm, it needs numerical data. They cannot work on categorical data. So machine learning is basically maths. Maths algorithms are there, statistics it uses. So statistics needs numbers. So we need numbers instead of these categories. So we have to pre-process the data and convert categorical data into numerical data. So we shall do the data pre-processing. For pre-processing, we also have a module called pre-processing that is a part of sklearn library. So we import pre-processing from sklearn, and in pre-processing we have an encoder called label encoder. This label encoder checks the labels and assigns a numerical value to that label. So we had a column, marital status. These are labels. How many labels are there? Single, married, divorced. There are 3 labels, so each shall be assigned a number and each shall be converted. So let us see how to do this. First of all, we have called the object of label encoder, stored it in label encoder variable. Now we are using this variable to transform our data and marital status column. After transforming it, we are storing it in the same column, t.marital status. So now our categorical data would have been converted into numerical data. So on our unique values, how many unique values are there? We can check using the .unique method. So we see there are three categories: 0, 1, 2. And if we see after conversion how our marital status column looks like, so we have taken that array of marital status, we have reshaped it into a row. It was a column, we have reshaped it into a row. So after reshaping it, we shall see that this is our data, how our marital status column looks like: 2, 1, 2. So as we see there, 2, 1, 2 means 2 for single, 1 for married, 2 for single, 1 for married, then 3 and 0 for divorced. Same shall be the case. So this is how categorical data has been transformed to numerical data. Now we also have to convert refund and taxable income. Refund is also categorical, so we can use the same process. Label encoder.fit transform refund, it has been converted. Unique values, only 2 labels are there in this. Now to convert this taxable income, as we see the taxable income, this is everything is fine, just we have at the end k 4000. So we have to remove k and add 3 zeros and convert it into integer. So we put a loop on the entire length of taxable income. Now if our taxable income lasts for every ith index, at last if it has k in the string, then we have to take all the digits till last. To last means length minus 1, and then add triple zeros for 1000 and then convert it into integer. So this will transform our string to integer, remove k and add 3 zeros this line and store it into that place. Now after that we have to convert whole column to integer type, so we have converted d taxable as type string to as type int. After doing all these transformations, when we see t.info, we shall see that all our columns have become integer except the last, the weight column. This is object. This is fine as this is our target, which we have to check and predict, and there are 10 not null values. So after conversion, our data set looks like this: all integers, categorical data converted to numerical data, and we have got all the numbers needed to do our processing, train our model, and get our predictions. This is our target column. These are our attributes. So now the preprocessing is completed. Now we shall begin. There is one more type of encoder, one named one-hot encoder. In label encoder, it has converted each unique label to a number. In one-hot encoder, for each unique label, it converts it into a separate column and gives 1 if it belongs to that label. So single, married, divorced, 3 columns. First was single, so 1. Second was married, so 1. And single, then married, then divorced. So this is one hot encoder. This is also a type of encoder. As label encoder we used. So this can also do these same things. Now when we describe our dataset, we shall see all the columns have been converted to numerical part. So we got mathematical description for each column. After preprocessing, the second part comes. splitting our x and y, that is the data and target. So for x, we have taken all rows and first to second last column. We have to leave the last column. So we have taken first to second last column and all the values we have taken. And for target, we have taken the last column, all rows of last column. And we have taken all the values. So after printing, we shall see that we have got x and this is our y. We have separated our equation column and the remaining data. Now the main part of our any ML project, that is splitting the training testing data, importing the models and getting the predictions. So from sklearn.model selection, we have imported train test split. This function splits our data set into training data and testing data. So train test split, x column, our x is the training site and y is the target. Test size gives us how many values we want in our test data. So 0.1 means 10%. Now this gives us 4 values, that is x train and x test, y train and y test. So we had 10 and 0.1 in test, so one value will be in test, remaining 9 will be in training. 1 2 3 4 5 6 7 8 9. So this is our train, this is our y train, this is our x test, and this is y test. Now the most important thing is importing the model. Now from sklearn.neighbours, we import K-neighbours classifier. This is our KNN classifier. This is present in neighbours. So K-neighbours classifier we have imported. Now we will call this object, create an object of this class. In this we have to define how many neighbours. We have used k is equal to 3 and calculation, that is what distance calculation method we will use. For that we have defined Euclidean. We have got a classifier. Now we have to train the classifier. So for that classifier dot fit on training data we have trained x train y train. Now our model is ready. It is ready, it is fit on the training data, training is done. Y test was yes. Now we have to get the prediction for x test. So we will use classifier, that is our KNN model dot predict function. Give it the input, that is x test, and it will give us the prediction that is stored in ypad. And our ypad is yes. So we can see our KNN is working fine. Actual answer was yes and predicted answer is yes. So after training the model, getting predictions, the last part of any ML project is model performance evaluation, and for that major things that we need are confusion matrix, classification report, or and accuracy score, F score. So all these function methods are stored in sklearn.matrix library. So from that we have imported classification report, confusion matrix, and it is easy. Confusion matrix, it is always between the actual and predicted. So actual is stored in ytest and predicted is ypred, and same for classification report, ytest and ypred. So confusion matrix is this, classification report is this, it gives accuracy 100%, that is the F score, recall precision, everything is 100% because only one data was there. And if we want to predict for any sample or our own, we want to get any prediction, so we can create our own test. So we have given 0 for immigration, 2 that is divorced for marital status, and 90,000 for taxable income, and we can get our prediction using classifier.pred, and we have given our test data. and we get a prediction that yes, it is okay. The target for this is yes, it is evaded. So as we see, our test was 0 to 93,000. So 0 to 90,000, it was yes. So our KNN is working fine, it's giving very nice accuracy. So this was all about K nearest neighbors. Somewhat about the theory of what KNN is. K nearest neighbors, where K is equal to a odd number. We have used 3, so it will find the distance from all the neighbors from every other point and find the 3 closest neighbors. Check their answers, and whatever will be the majority, that will be the answer for our prediction. This is how the KNN works. This was the basic project for KNN. I hope you guys would have understood it, enjoyed it, and found machine learning somewhat simple, because only you have to import the functions and use them. There is nothing else. You can get documentation on Google. Colab is the basic platform to do all of this because it provides good amount of RAM. Otherwise, it is tough to run on your own system. See, 12 GB and 107 GB. So I hope you guys would have found machine learning interesting. Love the video, and I hope I was able to solve some of your problems for machine learning and make you understand the k nearest snappers. Thanks for watching the video. Thank you. Have a nice day.